This is a tutorial for the Crazy 2x3x3. Okay, and before I start, this puzzle has a strange twist to it. So, as you notice, if you move the center once, then you can move the top face twice. You can't move it just once because that gets stuck, but if you move it twice, then you can still move the puzzle. So, since that's the only case where you can actually move the center just one turn, I'm just going to refer to this whole move, 1, 2, and 3. I'll call that X. So that is X. Okay. Okay, so now the first thing you have to do is to figure out which piece controls whether the yellow side moves or whether the white side moves. Because as you can see, it's either the white side moves and the yellow side doesn't, or the yellow side moves and the white side doesn't. And if the way this works is it's always going to be a corner piece, and that corner piece will never separate from its inner corner piece, because the inner corner piece is what controls which side moves separately or with the circle. In my case, it's going to be this white, green, and red corner piece with this white inner corner piece. Because if you look here, the yellow side is moving with the circle right now. If you move it up to the top, then the white side is moving. But that means that it could be either this piece, that piece, or that piece. So to check, I'll take this piece and try it again. Since this is the only piece that's been used twice and still moves the whole side, that means that this is a piece that controls whether it goes with or without the circle. Okay, so the first thing to do is to take the white side, since that's a white corner piece, and solve all the outer edge pieces without worrying about anything else. So I have an orange here, so I need to put a red here. So just the outer edge pieces, white and red, white and orange. Next, I have to put in these two, white and blue and white and green, but I have to discover which edge piece goes where in relevance to this red and orange. So if I look here, I can move this around, and now I see the corner piece here matches with the red and the white, and this side is green, which means this side has to be white and green. That's right here. Now I'll put the last one in. Now I've completed my outer edge pieces for the white side. Now from here, I want to put in these corner pieces starting with this one, this white, green, and red. So to do that, I'm just going to take the whole layer, these three pieces, bring it to the opposite side, take the piece out, separate it from the edge piece, like that, and put the edge piece back while this corner piece remains outside. Now this piece has to go into here. So I'm going to take this edge piece, bring it to the top, and manipulate it so that I can match this and this piece. So since this is a white and green piece, I want to have the white and green piece here, because when I bring to the opposite side, if I turn this, now they'll match, white and green. And when I put them back, that piece is now in. And I want to do the same for the other pieces. And, okay, so right here, this piece will be white, blue, and red. That's right here. So move it up to the top. White and blue will match with white and blue. Okay. And now these two pieces will go over here. And whenever you're putting these pieces in, after you solve this piece, this white, green, and red, or whichever piece controls the sides, you want to make sure you avoid using this piece. So use this side where it doesn't involve this corner piece. So now to solve for these two, I match the white and orange and the white and orange. Okay, now I want to solve for these inner white corner pieces. And as I can see right now, even if I move it like this, nothing will solve because the whites are over here. There's only one way to move these to the other side, and that would be to take a piece like this and use X. So move the middle once, top face twice, and middle back. And although that swaps these two pieces, it also swaps everything that's over here. So now when I turn it, the white is in. From here I just want to replace so that all the whites are now at the bottom. And now I want to solve for this piece again. So solve for the edge piece. And now to solve for the corner pieces. Match the white and blue. Match the other white and blue. And now this is solved. And in this case, I ended up solving these inner edge pieces as well, but that won't always happen. Sometimes you'll have a case like this, where everything's solved except for 1, 2, 3, or 4 of these inner edge pieces. When that happens, you want to get this piece opposite this piece so that when you flip it, they'll match. And from here, you're going to use X, X, and then 2U, X, 2U, and X. And that'll switch these two pieces. Now from here, you want to solve for the top face, and you want to start with solving for the corner pieces. So the algorithm I'm going to use for this will swap the two corner pieces that are on the right, so this piece and this piece. And again, I want to make sure I avoid using this white, green, and red piece that controls the sides, or the inner circle will change again. So to avoid using that, I'm going to use the right side, top side, and the front side for this algorithm. So I'm going to start with this one in the back, left, and bottom. Then I'll use this side, and this side, and this piece will not be touched. So these two are already solved, so I don't want to change these. I want to swap these two and solve all the corners. So from here, with the two pieces that are mixed on the right, I'm going to do 2R, U, 2R, U inverted, 2R, 2F, U inverted, 2F, and then usually I do D and 2R, but since that changes the circle, from here I'm going to turn the, well first I'll just start with these three pieces in the front as I was before. I'm going to take the top face and move it over, U invert it, so that these pieces are not caught up. And I'll do 2F, 2U, 2F. And that'll solve for the top face and these pieces as well. And then from here, since I had to rotate these, I'll do 2R, 2U, 2R, 2U, 2R. And right now, as I'm looking at this, I ended up in a case where there's only 2 edge pieces that are not solved. When only 2 or 4 edge pieces are not solved, that means that I have something you might call a parity error. Because any algorithm I can use from here to switch any of these two pieces will automatically result in the inner circle to be switched as well, like this. For example, I've used an algorithm to solve all of these yellow outer edge pieces, but this inner circle has been switched. So, the way this one works is, it just means that any 2 of these pieces, so this piece and this piece, or this piece and this piece are switched. So all I have to do is flip them and solve again. So again, I want to avoid using this one. I'll keep that here, the bottom left in the back. And from here, I'll start with the yellow in the front. So I'll bring this one over to here and then bring this one over to here. So I'll do 2R, 2U. And as you can see, the piece that was once here will move over to here. The piece that was once here is now back here. So if I do 2R, this piece is now back here. So these two just switched. And from here, I want to solve again. So looking at the bottom face and the top face, I see that these two pieces are switched. So to solve for that, I just have to do, since they're right above each other, I just have to do X. 1, 2, 3. And that'll solve for this. And there's one other thing that changes. These two corner pieces, as well as these two corner pieces, switch. So I want to start with the white side first, and I want to solve for these two corner pieces again. So again, make sure you avoid using this piece that controls the sides. And just take this piece out onto the yellow side. So separate it, and then put these two back in. Now turn the cube, and put this one, swap this one with this corner piece. I've matched them and put them back in. Now for the last part. I've matched them. Now the white side is solved once again. Now the corner pieces are always going to start out solved once you do that. And now all you have to do is to solve for these edge pieces. And again, avoid using this. And since it's these three, I can first swap these two, and then the blue will be solved, and then swap these two. So I'm going to start out by swapping these two outer edge pieces. So with one in front and one in the back, I'll do 2R, 2U, 2R, 2U, 2R. Now, as I said before, that'll swap these two. But since I had to use two algorithms to solve for the whole yellow side, that means that this will swap once again and be solved. So now I want to solve the one in the front and the one on the right. So these two will switch. So one on the front, one on the right, avoid using this piece. And I'll do 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. That's how you solve the crazy 2x3x3. Thank you for watching.